Okay, so this other presentation is basically an accumulation of general advice, tips, and tricks for using the QH camera with SharpCap. I will try not to talk about calibration for this one. It is largely gleaned from a Zoom meeting for users of the camera that George Viscomi organized back in June, in which he then graciously edited and made available to us. So thanks, George, for putting that together. I believe that video is still available. Is that correct, George?
Yes, it is. You can get a link to it if you go to the group's IO, and it's about 30 posts back, and it's listed as recording of Zoom session on the QHY.
Okay,
So
great.
it's still, there's still a link.
Great. Okay, so I'm just going to jump right in. Let's start with a few GUI issues in SharpCap that people have noticed. One thing, as some people have discovered, is that there are getting a handle on which controls affect just the display on the screen versus which modify the actual captured data itself. In particular, I'm talking about display histogram stretch and image controls. They both can affect what we see on the screen, but one of them will only affect the screen. The other will also affect the captured data. Histogram stretch, play with it till the cows come home. It will only affect the display, but image controls we generally don't want to touch because they will actually alter the data on the disk. That's something that has bit me way back in the past, and I think others may run into that as well. And as a little tip, as some of us also have learned, you can move these controls around. So I put these three ones that I never use, pre-processing, image controls, and scope controls at the bottom. If you grab the little three-line menu, you can slide these up and down. So put the ones that are least or not used at the bottom. Next up, binning. Mark Bowie and Swery use one by one, and he's had good experience with the QHY cameras from the New Horizons business with that, so that's sort of a good starting point for us. One thing my understanding from that session is that more binning will probably not improve the signal to noise ratio with a CMOS chip that the QHY use as it might with a CCD. So basically, if you can see it in 2x2, you should still be able to see it in the data with 1x1 in a post-analysis if you just, enhance the contrast. So therefore, you can do the binning anyway in analysis later, but you can't undo that. So why throw away the spatial resolution? The other reason not to do binning is you risk running out of dynamic range. We're not sure whether this happens at the 12-bit A to D level or the 16-bit counter level, but that could be explored. The one case that was mentioned of maybe binning is if you have a huge oversampling, like really poor seeing, and binning gets you back to a little more undersampled, not undersampled, but a more typical sampling of 2 or 3 pixels across. Fits versus SCR, the big debate. Both of them are quite useful. The pros for fits that I learned are since it stores a single frame per file, that can make it easier to transfer, edit, and view it, because after all, we are looking at data frame by frame eventually. If you happen to be passing data on to some places that like it, that's a reason to do it, like Swery. And I believe fits will save more metadata, like the lat long and end of exposure, directly to the frames. The big advantage to that is, since you're not opening as many files during a capture, that might save you some bandwidth to disk and enable you to get to higher frame rates. But one risk I see with this is, what I don't know is, what happens if I run out of disk during the capture? Since all the timestamps are at the end of the file with SIR, do I lose all of my timestamps if I run out of disk versus just things from end of disk later? Some laptop hardware issues. Mark has found disk speed is probably the #1 controller of how fast you can capture. So use solid state disks. USB 3 if you can, because it's faster. Try different cables. Joan, I believe, has found that not all USB 3 cables are created equal. Sometimes they don't even work with the camera. Beware of long cables. You might lose some bandwidth. It can handle it, but it can, you gotta test the cable and don't use something longer than you really need to. A few other hardware issues. Always connect the 12-volt cooler power. Yes, all it does is run the thermoelectric cooler, the fan, and probably the dew heater. we technically can still talk to the camera and get data without it, but a cool chip really reduces hot pixels and avoids any loss of data by interference with hot pixels. And another tip is connect the camera at the start, not just 20 minutes later after you're aligned and ready to take data, because that way you're not cooling the chip down from an overheated state of having run for a while. You're only cooling it down from ambient temperature. Those cooler temp fluctuations, George, that you noticed with some versions of SharpCap, I have seen notices in later versions that might have been addressed. I don't know that for sure, but there are notes saying improvements to the thermal cooling, so that might be something to investigate. GPS antenna can come loose, so if you see bad data, maybe adjust the antenna, but as we saw from my 45-minute tirade, it can also be from calibration. Secure your cables on the scope with rubber bands or Velcro so you're not straining the connections, as well as not constantly flexing it and making the connectors loose. Treat your camera nicely. If don't thermal shock it. If it's cold outside, some people put it in a Ziploc bag before bringing it in to keep the condensation off. They reduce the thermal shock when bringing it in to maybe staging it in a garage if they bring it in when it's really cold out. So it's an intermediate step. And don't put it away wet, just like a horse. Let it dry off. If the cables are wet, my cables always get dewy up in here in the summertime. I try to leave them outside the box before I put it away. Another thing that I have found, these 12-volt connectors for the cooler are notorious for losing connection. Even if you press them in all the way, the tip is like just a fraction of an inch too short. So what I've done is put a blob of solder on the end. This is really easy to do. You just unscrew this tip so that you don't melt the thing while you're soldering it, and you put a little solder at the end. And the nice thing about this is that when you solder just this, not only can't you melt anything, there's no electronics to fry. So even sparky people can do this. Another problem people have noticed is these are round, slickery, and expensive cameras, and really easy to drop. So people have wanted a tether. I know George has demonstrated some tethers or at least attachment points he's made on other cameras. I happened to notice this when I was going across the interwebs on Christian's setup. He just attached what looks to be a piece of wire to the screw, one of the 4 screws on the back of the camera, and then attaches it to a hard point on the scope. So it has less of a fall if it does fall. Speaking of dropping cameras, people have mentioned these Bader click lock things. And this is on my Christmas wish list. So apparently the grip the eyepiece, or in our case, our heavy cameras by this entire inner surface. So really tight grip instead of just a tiny little set screw. So this is definitely on my to-do list. The infamous firmware upgrade, that got talked about. Basically, that is something a lot of us have been considering. So the pros for that, apparently the biggest thing is you get altitude data in the GPS log, which could be useful if you're maybe in a remote deployment where you might not trust Google Earth coordinates. You also get little bonuses like number of satellites, signal quality for the log. Mark says it might make it easier to determine when the almanac is obtained because there is no GUI light up thing like there is on the IOTA viddies that tells you when you have the almanac. The cons, biggest one, of course, is you could brick the camera. And it doesn't actually still give you any indication on a frame by frame or in the GUI basis that you have the almanac. It just might add data to the log that makes it easier to find that out later. So my verdict on this is it's not a requirement. As long as you have some separate altitude available to file your reports, bring your phone. It's a nice to have, but it's not a requirement. If you are going to go down where angels fear to tread, there is a SharpCap forum post that has, I think, a copy of Mark's instructions via Christian Weber or someone. And Mark has also said that he may make a video on this if we show enough interest. Determining exposure. I learned some more about that. I learned some more about this from Roger and Dave yesterday as well. This is still sort of a learning curve for me. Biggest thing I learned is we don't have to absolutely go after the quickest exposure possible. That is not the end all be all, because apparently our tools will get some intra-frame resolution by doing photometry on the exact DNR frames. You know, if it's a partial exposure, we know if it's 50% down, you know, on the D frame, we can assume that the disappearance happened 50% into the frame, so we can get some resolution there. If I'm wrong about that assumption, then somebody quickly speak up and slap me. But at the other hand, we don't want to go too slow either. So avoid saturation. There's a tool in SharpCap in the upper right. There's an FX menu. You can pick the highlight overexposed tool, and that will flash any overexposed pixels black, I believe. Why black was chosen instead of maybe a color, I don't know, but that is a tool to at least see that things are overexposed and you need to reduce exposure. Another rule of thumb: make sure at least 2 frames are captured at your chord, and yours may differ from the central chord. So for example, if I did a QHY occultation a few months back, I think it was like up to 10 seconds at central chord expected or something. Really faint star. I could barely reach it maybe with my 10-inch. So I was doing long exposures. I had to do like 5 seconds or something. So I'm really at the ragged edge of potential usefulness there. If I had to do like an 8-second exposure to see it, I'm probably not going to be getting useful data. This calculus can change for low magnitude drop events, as I think some people mentioned yesterday. We need more signal to noise than just barely seeing the star, because we need to see it when it goes dim, not just goes completely out. So a good tip that was mentioned from Dave, I think, was ensure both the asteroid and the star are visible separately well before the event. Like, set up at least 30 minutes beforehand where you can see them separate. And lastly, if you are changing parameters, Mark says the exposure is your first free parameter to change, and then maybe gain, but still keep it below 300. So don't just do like I once did and whack the gain up to try to get a shorter exposure. Because again, we don't need to change, we don't need to chase short exposures at the expense of everything else. Whacking the gain up just reduces dynamic range. So adjust exposure first. Dropped frames, basically try to avoid them. Every frame's time stamped independently, so it's not gonna affect later frames that aren't dropped. But if you drop a frame at the D, at the D or the R, you could lose the entire event if it's only one frame, or at least you're losing an entire frame's width of resolution. And remember, we may be getting subframe resolution if you don't have drop frames, so it could be a big loss. Big thing I also learned over the years: we cannot trust the SharpCap GUI drop frame counts. The one at the bottom and the one at the top at the pop-up when you end the capture, both can underreport. I've never seen them overreport, but they can underreport. They can say 0 frames dropped, and you can still drop a frame. The only definitive answer comes from a PyOTA or PyMovie analysis. I have a little quickie Python script that I wrote that, since I do fits, those are really easy to analyze because the metadata is easy to read. So I have a quick script that I do in the field when I run a test capture, and I can boom, do an analysis and say, do I have a drop frame? I'm not going to suck up time. I walk through all of Mark's recommended profile settings, but this will be in my presentation online, and I'll refer to the YouTube video where Mark goes over this. These are basically settings that the New Horizons folks have found to be useful, so they're a great starting point. I just added my best guess as to why we do these settings. So let me jump through all of this, because this will just suck up time and you can read it later. And there's some general settings, yada, yada, yada. But in the field best practices, I do want to cover this. Try to make sure the GPS almanac is downloaded. As I said, we don't have a GUI indication like we do on the IOTA vidis of when the leap seconds have been applied, but you could do it one of 2 ways. Wait 20 minutes while it's locked, because the almanac only takes 12.5 minutes. So if you've been locked for 20 minutes, you should be guaranteed to have the leap seconds. Or you can be a little more proactive. When the GPS is first locked, synchronize your time on your PC, then watch the little GPS window that shows the difference between system and GPS time. It should now say pretty much 0 because you synchronize the clocks, right? After a few minutes, you might notice it'll jump to like 3 seconds. That's when the leap seconds have been applied. The GPS time will shift because the almanac's been downloaded. And now it won't say, hey, I have the almanac, but it'll at least jump. And your OS time isn't going to lose 3 seconds in 15 minutes. So when that happens, hey, I know I have the almanac, synchronize again, you're off to the races. Do a test capture, look for drop cap frames. I've had this happen where I thought I had a good profile and it started dropping frames in the field for some reason, so I had to back off exposure. After the event, a good sanity check is check your GPS time from your camera with like WWV or Naval Observatory, just as a sanity check to see that you're within reason. And lastly, resources. Again, this is all gleaned from the big Zoom meeting that we had. So thanks everybody that was there for your input. I think it was Rick Bria, Dr. Mark Bowie, David and Joan Dunham, Kevin Green, Bill Hanna, Roxanne Kamen, Bob Meadows, John Moore, Ned Smith, and George, of course. SharpCap forums have a lot of info, as I mentioned in my previous presentation. There's a post on the firmware upgrade. Look on YouTube for the Lucy mission channel and SharpCap configuration. There's a good discussion of what they do to set up SharpCap with these cameras. Okay, thanks. That's it.
Hey, Kai,
Yeah.
just one mention about one thing that actually Dr. Bowie brought up was the raising that offset.
Yes.
So it wasn't sitting at 0, because that just cuts off your black level.
Yep. Yeah, that's a good idea. I as I said, since I didn't want to talk all day about the QHY, I kind of glossed over all the settings stuff, but that is definitely in his list of settings in the YouTube video, and it's in my slides that I zipped through here. But yeah, that's a good point.
Okay, thanks. Nice.
Kai, Kai, this is Steve. I have a couple comments. One was on binning. The other one advantage of binning is it'll reduce the necessary bandwidth on the hard drive, so it'll help avoid problems with losing frames. If you're really pushing it, then that's one thing. Binning is one thing you can do to alleviate that issue.
Yeah, and that was, and I've done that too. And the thing that I was getting from Mark is that he would back off maybe frame size. I don't know which one he would back off first on that, or even exposure.
If you can reduce the region of interest, if you can reduce the frame size, that does the same thing. So, and Mark,
right.
For his own purposes, he may have other guidelines he prefers people follow.
Exactly. So, right. So a lot of the profile settings I'm going here probably come from a Lucy perspective. They may have different tools, and they're also doing astrometry on it. Well, really, then I don't think there's doing as much astrometry on our stuff as photometry, but his tools may use more field stars to do alignment than say PyMovie. So,
right. Yeah. And then the other thing I'll mention is I believe that Hristo said that SharpCap will in the future support the ADV format. So some people may get to that format. It has some nice features to it.
Yes, I've heard of that talk as well. Yes.
So just something to keep an eye out in the future.
Yep.
Okay. And thanks.
Sure. Anybody else?
Hi, Kai, Ted. If we were invited at some point in the future by Mark to participate again in one of these events, and we were given a laptop with SharpCap on it, how much instruction should we expect to have to get on this problem or these problems to avoid issues in the field?
Oh, all the whole calibration thing tirade that I went on for 45 minutes, you mean?
Everything. That and
I would expect to be none of it. Because he's using an older version that we just haven't seen that problem on. I basically wasted, as Count Rugen says, I've just sucked 45 minutes of your life away. You probably, if we roll back to an early version of SharpCap, I think it's fine.
Oh.
I think if we go to, earlier than like the early 3.2s, maybe whatever he's using, like 6194. 3.2.6194. I think that's fine. The downside is you might miss other bug fixes. There may be other bugs I'm not aware of, like better control of the thermoelectric cooler. Because I've noticed sometimes on the New Horizons scopes, the fan like really zooming up fast on his versus a SharpCap.
So you can actually come up to speed pretty quickly just by going to the Lucy Mission channel and going through the videos there.
Yeah, it's a great resource. And it's more coherent probably than my presentations.
Can I ask? Let me just ask. I don't know. It's not a hostile question. A provocative question.
Yes.
I actually it may sound hostile.
No.
So we got the Sharp Cap here in the Westport Astronomical Society. We bought it mainly because the clock was faster, and it because I was interested. There are a lot, most of these asteroids are small, and so I'm thinking, well, how do we get the small ones? Well, we need a fast clock. We need something that can run really fast, and so that was kind of my intro into that. But if we're doing, for most people here, this is also an expensive device, so the question is this the most appropriate instrument for most people?
I don't know.
Kind of stuff.
That it might not be, because frankly, there are cheap, an IOTA Vidi plus I think one of the WATEC, however you pronounce the cameras, is probably cheaper.
The WATEC's not much. It's cheaper, but it's not much cheaper.
Okay, I don't know.
I guess, the other thing is, I think we all want to go to 2,000 stations.
Yeah, right. This is not. Yeah. I don't have the budget.
Is this the way to go? I don't know. I don't know the answer to the question. It's a question I'm asking.
We do have, we do still have.
I know the answer to the question, but I think we need to go on to the next presentation.
Yeah. Okay, let me stop.
Kevin and we can talk some other time about that if you like. I have a lot of thoughts on it.